Hello and welcome to week 5 of remote learning part 2. Today we are covering the volume of 3D figures. Just a reminder, volume is the three-dimensional space enclosed by a boundary or occupied by an object. So it'd be the space occupied by an object. Volume is always measured in cubic units, and that is how you would say it as well. So an example, we would write centimeters cubed, but how that reads would be cubic centimeters. All right, to find the volume of a rectangular prism, simply multiply its base, width, and height. If you remember from the area of a rectangle, the area of a rectangle is length times width, or base times height. So essentially what this right here is saying is that you take the area of the base and you multiply it by the height of the prism. And that's true for all prisms. Sometimes you'll have a triangular base, sometimes you'll have a pentagonal base. Either way, you find the area of the base and then you multiply it by the height of the prism. So in example 1, we have 13, 3, and 5, all of our base, width, and height, all labeled. So let's go ahead and write this out. So I have V for volume is equal to the base times the width times the height. Another way you could put that for the base is length. Length times width times height. It's the same thing. The length or the base of my shape, my prism, is equal to 13. The width is equal to 3, and the height is equal to 5. When I multiply all those together, that gives me the volume. So I have a volume of 195, and this is measured in centimeters, and we are using cubic units. So I have centimeters cubed, or 195 cubic centimeters would be how you would read that. And that's my volume. All right, so that's a rectangular prism. Let's go ahead and look at this triangular prism in example number 2. So I mentioned before, you're finding the area of the base and you're multiplying it by the height of the shape. Holds true here. So I have, for my formula, volume is equal to area of the base, which is a triangle, 1/2 times base times height, times the whole height of the prism, which we'll call the length in this case. So we'll call that L. So volume is equal to my area of the base, 1/2 times, well, the area of the base tells me to use the base of the triangle and the height of the triangle. So I have 8 times 3 times the length, which is 12. When I multiply the area of the base together, 8 divided by 2 is equal to 4. 4 times 3 is equal to 12, so I end up with 12 times 12. 12 times 12 is equal to 144, so my volume is equal to 144 centimeters cubed, or 144 cubic centimeters. All right, so those are 2 examples of how prisms work. Find the area of the base, multiply it by the height. Now we're going to go ahead and look at pyramids, which are just a little bit different in how they work. So a pyramid consists of 1/3 the space of the prism with the same base and height. So therefore, the formula for volume is 1/3 times the area of the base times the height of the shape. So in example 3, I have a square-based pyramid. So I'm working with, for my volume, still 1/3 times area of the base. It's a square, so I'm working with length times width times height of the whole figure. When I look at my figure here, I notice that I have the square bases, 9 and 9, those are labeled. I'm not seeing a noticeable height. Just for this scenario, let's just go ahead and say that the height is equal to 15 centimeters. There's no reason for that. I'm just saying, let's say it's 15. So in any example with the square-based pyramid I would give you the height. You wouldn't be expected to find that unless I was giving you a little more information than what I'm giving you in this problem. So I have the formula 1/3 times length times width, both of them happen to be 9 because it's a square, times height, which I said was 15. When I multiply that out, that gives me a volume of 405 cubic centimeters. Much like pyramids, spheres also work a little bit different, even more so because they have their own formula. The volume of a sphere is represented by the formula V for volume is equal to 4/3 times pi times the radius cubed. So in example 4 here, it says find the volume of the sphere below. It gives me a diameter of 24 inches. We've talked before about how if it gives you a diameter, you have to divide that by 2 to find the radius. 24 divided by 2 is equal to 12, so I know my radius is equal to 12. So my formula, volume is equal to 4/3 times pi times the radius cubed. If I were to take my information and plug that in, that gives me 4/3 times pi times radius of 12, 12 cubed. All right, let's rearrange this. 4/3 times 12 cubed. 12 cubed is equal to 1,728 times pi. 4/3 times 1,728 could be a little messy. It might be beneficial when you're solving a problem like this to multiply the fractions together first, remembering that every whole number is set over 1. So that really gives you 6,912 over 3 times pi. This happens to work out really nicely where that division is a whole number. It ends up with 2,304 times pi. That's not always going to work out. If that's the case, just give me 2 decimal points and then we'll move from there. When you multiply by pi, that gives you a total volume of approximately 7,238 and 23 hundredths inches cubed. All right, that's where we're going to stop for today. If you would like to see example number 5, I'll post that in an optional video, but that is not something that we will be looking at in our weekly assignment this week, but very possible that you may use it in the future, especially if you're looking into an engineering field. So that might be something that you might want to look at.